Look up tonight and find that faint, elongated smudge in the constellation of Andromeda, the only galaxy beyond our own that the unaided human eye can detect. For most of your life, it has been nothing more than a ghostly oval, a barely there patch of light you could cover with the tip of your finger held at arm's length. You have stared at it countless times without ever feeling the impact of what it really is. That smudge is the Andromeda Galaxy, a spiral metropolis of 1 trillion stars, a swirling maelstrom of light, gas, dust, and dark matter so colossal that our own Milky Way, with its mere 100 billion suns and 100,000 light-year breadth, is little more than its younger, smaller sibling. Andromeda is older, brighter, more massive, and, crucially, moving. Right now, this very second, it is hurtling toward us at 110 kilometers per second, 70 miles every time your heart beats. The collision has already been scheduled by gravity itself. The countdown began billions of years ago and is now measured in mere billions left to go. This is not a distant threat. It is our cosmic destiny written in the inexorable language of orbital mechanics. If the idea of a trillion-star galaxy charging across the void has just made the night sky feel suddenly alive, if the ground beneath your feet seems a little less permanent, then you are ready. Tonight, we strip away every comforting illusion of distance and safety. We are going to plunge into the true, brain-breaking scale of Andromeda until the numbers themselves collapse under their own weight. Take a breath, hit like, subscribe to Cosmo Depth, and hold on. Because once you truly see Andromeda for what it is, the universe will never feel small again. We begin. The story of Andromeda is not just the story of a galaxy. It is the story of humanity being repeatedly, brutally demoted from the center of everything. For 1,000 years, that faint smudge in the night sky was nothing more than a curiosity, a celestial footnote. The Persian astronomer Abd al-Rahman al-Sufi spotted it in 964 AD and recorded it in his book of fixed stars as a little cloud, a delicate poetic name that would cling to it for centuries. To every stargazer who followed, from medieval Islamic scholars to Renaissance Europeans, it remained exactly that, a nebulous cloud, a hazy blemish drifting among the sharp points of real stars. No one imagined it could be anything more. That comforting illusion lasted until the early 20th century, when the universe began to grow teeth. Astronomers like Harlow Shapley had already kicked us out of the galactic center, proving the sun was just a suburban star near the edge of the Milky Way. But even then, the Milky Way was still the entire universe, a single, majestic island of a few 100 billion stars, with everything else, those strange, spiral nebulae, mere wisps of gas inside it. The great debate of 1920 between Shapley and Heber Curtis crystallized the question. Were the spirals local clouds or distant island universes? The astronomical establishment leaned hard toward the former. Our galaxy was the stage, and everything else was scenery. Andromeda, the brightest and closest of those spirals, sat at the heart of the argument. To admit it was another galaxy was to admit the universe was vastly larger and humanity vastly less significant than anyone was ready to accept. The little cloud was not just a patch of light. It was the final barrier between a cozy, human-centered cosmos and the cold, infinite abyss we now know is real. And in the end, it was Andromeda itself that tore the barrier down. Washington, D.C., April 26, 1920. The auditorium of the National Academy of Sciences was packed. Two men walked onto the stage, and the fate of the entire universe was about to be decided in 90 minutes of slides, chalkboards, and barely concealed intellectual combat. This was the great debate, and it was no polite academic seminar. It was a duel between two visions of reality, one cozy and human-scaled, the other so vast it felt like blasphemy. Harlow Shapley strode in like a general, charismatic, confident, fresh from proving that the sun is nowhere near the galactic center. He had already delivered one devastating blow to human ego. Now he defended the fortress. The Milky Way is everything. In his model, our galaxy was a colossal, flattened disk, perhaps 300,000 light-years across, a number so large it sounded insane at the time, with the sun exiled to the suburbs. The spiral nebulae, including that persistent little cloud in Andromeda, were nothing more than gas clouds or star clusters trapped inside our single, all-encompassing island universe. To Shapley, the cosmos had room for exactly one galaxy, ours. Across the lectern stood Heber Curtis, quieter, more reserved, but armed with a far more dangerous idea. He argued that the spiral nebulae were island universes, separate galaxies every bit as grand as the Milky Way, floating in an ocean of intergalactic space so immense it dwarfed comprehension. Curtis pointed to the faint novae flaring in Andromeda, exploding stars that were hundreds of times dimmer than any known nova in our own galaxy, meaning they had to be millions of light years away. He highlighted the blue shift of Andromeda itself, proof it was approaching us, not orbiting like some local cloud. And he dared to sketch a universe of billions of such galaxies stretching to infinity. The room crackled with tension. One vision kept humanity inside a single, majestic, but finite home. The other flung us into a cold, infinite abyss where our galaxy was just one speck among countless others. Shapley spoke with swagger. Curtis spoke with evidence. Neither man knew it yet, but the weapon that would settle the fight was already being built in California. A 100-inch telescope on Mount Wilson that would soon turn the little cloud into a battlefield where human pride would finally, irrevocably, lose. The great debate ended in a draw that night, but the universe had already cast its vote, and it was not on our side. The great debate ended not with a bang, but with a polite murmur. No knockout blow, no concession speech. Both men left the stage convinced they had won, and the audience walked away more confused than when they arrived. Shapley had correctly banished the sun from the galactic center. Curtis had correctly seen the spirals as separate realms. Yet neither could prove the distance to Andromeda with the precision needed to end the argument. The universe simply refused to sit still for measurement. It was the last dying gasp of humanity's obsession with being special. First, we placed Earth at the center of everything. Copernicus wounded that pride. Then, we placed the sun at the center of the galaxy. Shapley and others finished the job. Now, we were clinging to the Milky Way as the final, ultimate container. The last fortress where humanity could still claim cosmic significance. To admit that the little cloud in Andromeda was another galaxy, as large or larger than our own, was to be demoted one final crushing time. From center of the universe to ordinary star to ordinary galaxy in an endless sea of galaxies. The psychological stakes were enormous. Many astronomers resisted, not because the evidence was weak, but because the implications were unbearable. But the evidence would not be denied forever. That faint smudge was beginning to betray secrets no local nebula could possess. A clear spiral structure visible on the best photographic plates. Rotation speeds that matched what we expected of an entire galaxy, and those mysterious novae, far too dim to be inside the Milky Way unless the distances were staggering. The universe was whispering that Andromeda was not a cloud. It was a continent. All that was missing was a measuring tape long enough to reach it. The stage was set for one man, one telescope, and one discovery that would finally kick us out of the last center we had left. That man was Edwin Hubble. And the telescope waiting for him on a California mountaintop was about to make the little cloud explode into something so vast it would swallow every comforting illusion humanity had ever held about its place in the cosmos. October 1923. High on the wind-scoured ridge of Mount Wilson in California, under the great iron dome of the observatory, stood the most powerful eye humanity had ever turned toward the heavens. The 100-inch Hooker telescope, a silvered mirror so large it weighed tons and could gather more light than every telescope that came before it combined. Night after night, Edwin Hubble, the former lawyer, Rhodes Scholar, and heavyweight boxer who had traded courtrooms and boxing rings for the cold silence of the cosmos, sat hunched over stacks of fragile glass photographic plates, each one exposed for hours to the faint, mysterious glow of the Andromeda Nebula. He was searching for something incredibly specific, a single, variable star whose gentle, rhythmic heartbeat could finally settle the greatest question of the age. Variable stars are those rare beacons whose brightness rises and falls in predictable cycles, like distant lighthouses sweeping the dark. Among them, the Cepheid variables are the most precious because their outer layers swell and contract in a perfectly regular rhythm, almost like a cosmic heartbeat you can set a clock by. The longer the period between one peak of brightness and the next, the intrinsically brighter the star actually is. This exquisite relationship was uncovered in 1912 by Henrietta Swan Leavitt, working quietly at the Harvard College Observatory among thousands of stars in the Magellanic Clouds. Imagine a row of identical lighthouses where the most powerful ones flash slowly and the weaker ones flash quickly. Time the flashes. Know the true power. Then compare that to how dim the light looks from your ship, and the distance to shore reveals itself with almost mechanical certainty. Leavitt had gifted astronomy its first true cosmic yardstick, a ruler that worked across the void. On the photographic plate exposed the night of October 6, 1923, Hubble spotted a promising star near the edge of the Andromeda spiral and carefully marked it with an N for nova. But when the next plates came in, the star refused to behave like a one-time explosion. Instead of fading into darkness, it rose again, dimmed, then rose once more in a steady, unmistakable cadence. Hubble's hand moved quickly across the glass. He scratched out the N and wrote VAR in bold red ink. He had found his Cepheid, the first ever identified inside the Andromeda Nebula. He measured the period, applied Leavitt's period luminosity law, and calculated the star's true, absolute brilliance. Then he compared that blazing intrinsic power to the almost invisible speck it appeared to be on his plates. The number that emerged was so enormous it felt like a physical shock. Roughly 900,000 light-years. In that single, quiet moment, with nothing more dramatic than a pencil, a stopwatch, and a glass plate fogged by ancient photons, Hubble shattered the old universe and gave birth to the one we know today. The little cloud was no cloud at all. It was a separate galaxy, a spiral empire of stars as grand as our own, floating in a darkness far greater than any mind in 1923 was ready to accept. That one number, 900,000 light-years, landed like a thunderbolt. Harlow Shapley had fought to keep the universe big, but still contained. A single Milky Way, roughly 300,000 light-years across, with the Sun far from its center. Yet everything still safely inside one galactic fortress. Hubble's measurement blew the walls apart. If a single star in Andromeda was already 900,000 light-years away, the entire spiral had to lie far beyond the borders of our galaxy. Curtis had been right all along. The spirals were island universes, separate cities of stars adrift in an ocean of emptiness so vast it swallowed every previous conception whole. In a single quiet calculation, the known universe exploded in size by orders of magnitude. Our Milky Way went from being the entire cosmos to just one island among countless others, an ordinary spiral in an endless cosmic sea. Hubble's first distance would later be refined to the modern value of about 2.5 million light-years, but the revolution was already complete. The philosophical shockwave was absolute. Humanity, already exiled from the center of the solar system and then from the center of its own galaxy, now found itself living on an ordinary planet, orbiting an ordinary star near the edge of an ordinary galaxy in a universe that suddenly contained billions of others. It was the final crushing demotion and the most liberating one. Stand outside tonight and let the real scale hit you. The photons, now slipping into your eyes from Andromeda, left their home galaxy 2.537 million years ago. When they began their journey, our ancestors were still Homo habilis, barely upright, chipping the first crude stone tools on the plains of Africa. The light you see has outlived entire species, entire genera. It has crossed a gulf so wide that the rise and fall of dinosaurs, the age of mammals, the birth of humanity, all of it happened in the time it took those photons to reach us. Every glance at Andromeda is a glance backward through almost the entire story of life on Earth, a silent reminder that the galaxy now rushing toward us has been watching our world evolve long before we ever looked back. That staggering distance, 2.537 million light-years, is only the first shockwave. It is the cold, empty space we have to mentally traverse just to reach the edge of Andromeda, a gulf so wide that the light we see tonight left before our species existed. Yet distance is merely the doorway. Step through it, and the true monstrosity of our neighbor begins to reveal itself. Calling Andromeda a galaxy feels almost insulting, like calling an ocean a puddle. Within the local group, our cosmic neighborhood of more than 50 galaxies, Andromeda is the undisputed titan. Where the Milky Way's visible disk spans roughly 100,000 to 120,000 light-years, Andromeda's bright spiral arms stretch across an astonishing 220,000 light-years, more than twice our width. Imagine laying the Milky Way flat like a compact disc. Andromeda would be an old-school vinyl record, dwarfing us in every direction. But even that understates the beast. Peer deeper with modern instruments, and you discover its faint stellar halo, a spherical shroud of ancient stars and scattered globular clusters, ballooning outward to at least 500,000 light-years from the core, and possibly much farther. Tidal streams and starlight traced by the deepest surveys show tendrils reaching out 700,000 light-years or more. In the most sobering maps, the outermost fringes of Andromeda's halo are already brushing, overlapping, and beginning to merge with the outer halo of our own Milky Way. We are not separated by a comfortable void. We are already touching. Two galactic halos, each the size of a small universe in its own right, are gently sliding into one another like ghost images on a double-exposed photograph. The collision has not waited for the bright disks to meet. It began millions of years ago in the dark, in the sparse outer suburbs where gravity speaks in whispers. The true scale of Andromeda is not just bigger than we thought, it is already here. Now come the stars. The Milky Way, for all its splendor, is thought to host somewhere between 2 and 400 billion of them. Andromeda laughs at that number. The best estimates put its stellar population at roughly 1 trillion, 1,000 billion suns, locked in a single, majestic whirl. To feel the weight of that figure, imagine trying to count them at 1 star per second, without sleep, without pause. You would need more than 31,000 years just to finish the job. Andromeda is not merely larger. It is a richer, more luminous empire, blazing with the combined light of 10 times as many nuclear fires as our own galaxy. Yet stars alone do not tell the full story of dominance. Mass is what truly rules the cosmic dance. For decades, astronomers believed Andromeda outweighed the Milky Way by a comfortable margin, but the latest, most careful measurements, using the subtle tug of orbiting satellite galaxies and the motion of stars within its halo, have narrowed the gap. Still, Andromeda comes out on top, roughly 1.5 trillion times the mass of the Sun. Compared to our own galaxies, 1.15 trillion solar masses. It is heavier, more commanding, the gravitational king of the local group. Every galaxy in our neighborhood, including the Milky Way itself, feels its pull more strongly than any other. Andromeda sits at the center of our local web like a massive spider, dictating the slow drift of everything around it. And here, the mystery deepens. Only about 15% of that immense mass shows up as stars, gas, or dust. The ordinary stuff we can see and photograph. The rest, a crushing 85%, is completely invisible. Dark matter. A silent, ghostly scaffold that outweighs all the shining stars by nearly 6 to 1. Without its unseen grip, Andromeda's spiral arms would fly apart. Without it, the galaxy would never have grown so large in the first place. Dark matter is the hidden skeleton that gives Andromeda its true, terrifying scale. The invisible hand that has already reached out across the void and begun pulling our own galaxy into its embrace. The dark matter halo is the silent colossus that truly defines Andromeda's dominion. It is an invisible, almost perfectly spherical cloud of exotic particles. No light, no heat, no interaction except gravity, stretching out to roughly 1.5 million light-years from the galaxy's heart. The bright spiral we admire in photographs is merely the tip of the iceberg. The visible disk is a delicate 220,000 light-year ornament suspended in the center of a dark sphere 7 times wider. Without that unseen scaffolding, the trillion stars would have flown apart long ago. The entire galaxy is literally built on darkness. To make the scale feel real, shrink the universe down to something you can walk around. Imagine the visible Milky Way as a dinner plate 12 inches across. Andromeda's bright disk becomes a serving platter about 24 inches wide, sitting roughly 20 feet away across the room. That's the 2.5 million light-year gap. Now add the dark matter halos. The Milky Way's invisible bubble swells to 8 feet across, while Andromeda's grows to a ghostly 10-foot sphere. Even at this tiny scale, the two bubbles are already overlapping, their edges intermingling like smoke from two invisible fires. In the real universe, the merger of those halos began hundreds of millions of years ago. This is why Andromeda is not drifting away like nearly every other galaxy in the observable cosmos. While the rest of the universe rides the great expansion outward, Andromeda is fighting the tide, pulled inexorably by the combined gravity of its own monstrous dark halo and ours. It is closing the gap at 110 kilometers per second, fast enough to cross the United States coast to coast in 40 seconds or circle the entire Earth in 6 minutes. In the patient language of cosmic time, that speed is blistering. The bright disks have 4 billion years left before they meet, but the dark halos are already shaking hands across the void, their mutual pull growing stronger with every passing millennium. The collision is not coming. It has already begun. And dark matter, the invisible giant no one can see or touch, is the one doing the driving. Andromeda's dark matter halo is not just big. It is a gravitational titan that sculpts the entire local group, bending space-time across millions of light-years and dragging dozens of satellite galaxies along in its wake. That invisible sphere is the true measure of the beast, a structure so colossal that the bright spiral we photograph is merely the glowing heart of something far larger, far subtler, and far more powerful. Gravity does not care what we can see. It only cares about mass, and Andromeda has it in abundance. Yet to truly know our neighbor, we must leave the cold outer halo and plunge toward the center, into a galaxy that is anything but calm. Andromeda is a barred spiral, grander and more tightly wound than our own, its arms laced with crimson star-forming regions and threaded by dark rivers of dust. But the real drama lies at its core. For decades, astronomers stared at the heart of Andromeda and saw something impossible. 2 distinct nuclei glowing side by side, labeled simply P1 and P2. The sight sparked wild theories, 2 supermassive black holes locked in a billion-year dance, the corpse of a devoured galaxy still smoldering at the center. The truth, uncovered by Hubble Space Telescope images sharp enough to resolve individual stars, is both simpler and stranger. There is only one supermassive black hole, a true monster weighing between 100 and 230 million suns, 30 to 50 times heavier than the one sleeping in our own galactic center. The double appearance is an illusion created by perspective and motion. P2 is the black hole itself, hidden behind a veil of dust. P1 is a dense cluster of old red stars caught in a wildly eccentric orbit, swinging so close to the black hole on one side that their combined light outshines everything else, like a bright lantern carried around a dark throne. That single black hole, quiet now, but capable of swallowing entire star systems, is the gravitational tyrant ruling 1 trillion suns. Every orbit in Andromeda, from the closest star to the farthest globular cluster, answers to its command. It is the silent conductor of a symphony so vast we can only glimpse its edges from our distant suburb. A reminder that beneath Andromeda's serene spiral, beauty lies the same ferocious violence that built every great galaxy. Mergers, cannibalism, and the relentless hunger of gravity. Beyond the crowded core, Andromeda's disk spreads out like a vast rippling sea of stars. But it is far from the calm, flat plain we often imagine. Unlike the Milky Way's relatively tidy disk, Andromeda's is visibly warped. Its outer edges bent upward on one side and downward on the other, like a vinyl record left too close to a flame. This distortion is the scar tissue of ancient violence. Gravitational encounters with massive companions that slammed into Andromeda billions of years ago, twisting its structure the way a passing speedboat warps the surface of a lake. The most dramatic event happened roughly 2 billion years ago, when a large satellite galaxy plunged deep into Andromeda's heart, sending shockwaves that still echo in the warped rim today. Threaded through that warped disk are broad, sweeping dust lanes and 2 dominant spiral arms that coil outward in a breathtaking grand design pattern, more clearly defined than anything in our own galaxy. These arms are cosmic nurseries, dark rivers of gas and dust, squeezed by density waves until they collapse under their own weight, igniting chains of brilliant new stars that light the arms in sapphire and ruby. Where the Milky Way traces 4 major arms, Andromeda's structure is messier, more chaotic. Splintered segments, broken rings, and faint feathers of material hinting at a turbulent past of mergers and tidal tearing. Orbiting this behemoth is a retinue of more than 20 dwarf galaxies, locked in desperate elliptical paths like moths around a flame. The brightest companions, M32 and M110, are stark reminders of Andromeda's cannibalistic hunger. M32 in particular is a strange, dense nugget, an elliptical galaxy stripped almost bare, believed to be the naked core of a once larger spiral that Andromeda devoured billions of years ago. The giant's tides ripped away its outer layers, leaving only a compact fossil of old stars still plunging through the halo. These satellites and the faint stellar streams trailing from their disrupted bodies act as cosmic tracer bullets. Like iron filings sprinkled around an invisible magnet, they map the shape of Andromeda's dark matter halo in exquisite detail. The picture that emerges is startling. The halo is not a perfect sphere but prolate, elongated, football-shaped, stretched along the axis of the galaxy's spin. That subtle deformation will play a crucial role when the halos of Andromeda and the Milky Way fully merge, guiding how the 2 dark skeletons intertwine long before their bright disks ever touch. The violence that warped Andromeda's disk and devoured its companions is only a preview. The main act is still to come, and we are next on the menu. Andromeda is not a frozen portrait hanging in the sky. It is a living, breathing colossus, a trillion-star engine of birth and annihilation, constantly reshaping itself under the push and pull of gravity, dark matter, and the silent explosions of dying suns. Every warped ripple in its disk, every shredded satellite, every flare of star formation along its majestic arms is a reminder that on galactic scales, change is the only constant. It is creation and destruction woven together on a canvas so vast that a human lifetime is less than the blink of an eye. We have measured the beast, a bright spiral 220,000 light-years wide, home to 1,000 billion suns, wrapped in a dark matter halo that balloons to millions of light-years across, all of it racing toward us at 70 miles every single second. Numbers that large stop meaning anything to the human mind, yet they describe something real, something already in motion, something that has been falling toward the Milky Way for billions of years. Because we are not spectators watching from a safe distance. We are the other dancer. The Milky Way and Andromeda are the twin giants of the local group, locked in a gravitational waltz that began when both galaxies were young. For billions of years, their mutual attraction has been tightening the spiral, slowly, patiently, irresistibly drawing them together. In roughly 4.5 billion years, the bright disks will finally meet in the first fiery kiss of a merger that will reshape both galaxies forever. That timing is no coincidence. The Sun is already 4.6 billion years old. In almost the exact moment the galaxies collide, our star will swell into a red giant, ballooning outward to swallow Mercury, Venus, and very possibly Earth itself. The fate of our planet and the fate of our galaxy are bound by the same inexorable clock. While the Sun dies in fire, the Milky Way will be reborn in the greatest cosmic spectacle our corner of the universe will ever witness. 2 trillion stars, 2 dark matter titans, one inevitable embrace. The collision is not coming. It is already written in the stars we see tonight. For decades, astronomers treated the Andromeda-Milky Way collision as an ironclad certainty, a cosmic appointment etched into the fabric of gravity itself. But in recent years, fresh data from NASA's Hubble Space Telescope and the European Space Agency's Gaia mission have introduced a thrilling twist, one that adds layers of uncertainty to the story we thought we knew. Gaia, launched in 2013, is humanity's most precise stellar cartographer, mapping the positions, distances, and motions of over 1 billion stars in our Milky Way with jaw-dropping accuracy down to micro-arc seconds. By tracking the subtle side-to-side drift of stars in Andromeda's outer regions against distant background galaxies, Gaia's observations have refined the galaxy's tangential velocity, its sideways motion relative to us, to about 76 kilometers per second, higher than earlier estimates suggested. Combined with Hubble's razor-sharp imaging of Andromeda's stellar streams and proper motions, this has allowed scientists to model the impending encounter with unprecedented detail. The result? A 50-50 chance of a direct, head-on smash-up within the next 10 billion years. While Andromeda is still barreling toward us at its radial speed of 110 kilometers per second, the boosted tangential component means it could glance off our galaxy like 2 passing ships in the night, missing the catastrophic core crash by a cosmic hair. In that scenario, gravity would sling Andromeda back around for a second, more decisive encounter billions of years later, ensuring a merger but on a slower, more dramatic timeline. This newfound wrinkle doesn't cancel the collision. Our galaxies are gravitationally bound, after all. But it transforms the event from inevitable apocalypse to a high-stakes dance where the outcome hangs in delicate balance. But let us now imagine the most spectacular outcome, a direct, head-on collision. The word collision conjures images of screeching metal and shattering glass. Yet on galactic scales, the drama is far stranger and far more beautiful. Galaxies are not solid objects. They are ghostly congregations of stars separated by distances almost too vast to comprehend. The average gap between stars in the disk is millions of times larger than the stars themselves. When Andromeda and the Milky Way finally overlap, the chances of any two individual suns actually smashing together are effectively zero. The stars will sail past one another like two vast flocks of fireflies drifting through the same patch of night, close enough to feel the gravitational whisper, yet almost never touching. The true violence will happen in the gas. Scattered between the stars are enormous clouds of hydrogen, helium, and dust, the raw material of future suns. When the two galaxies plunge into each other, these clouds will slam together at hundreds of kilometers per second. The shock waves will compress the gas with brutal efficiency, squeezing it until gravity takes over and triggers a galaxy-wide orgy of star formation. Imagine two storm fronts colliding, but instead of rain, the sky erupts in newborn stars, millions of them igniting in a blaze of ultraviolet fire. The merged galaxy will briefly shine many times brighter than either parent ever did, its spiral arms rewritten in brilliant sapphire and ruby as fresh stellar nurseries flare to life. It will be the greatest fireworks show the local group has ever seen, a cosmic celebration written in light and gravity, triggered by the simple, unstoppable fact that 2 trillion suns have finally decided to become one. Yet the stars themselves are only bystanders. The real sculptors of the merger are gravity and the invisible halos that cradle each galaxy. As the dark matter cocoons of Andromeda and the Milky Way begin to overlap fully, their immense masses will reach out across millions of light years and begin to yank. Tidal forces, the same gentle push and pull that raise Earth's oceans, will become monstrous on galactic scales, stretching both galaxies into long, glowing streamers of stars like taffy pulled in slow motion. Spiral arms will unravel, neat, orderly orbits will dissolve into chaos. Stars that have circled peacefully for billions of years will be hurled onto wild, elliptical paths, some flung outward into vast tidal tails that will glow for hundreds of millions of years. Others dragged inward toward the merging cores. Over the next several billion years, the 2 galaxies will pass through each other multiple times, each encounter more intimate than the last, until friction and dynamical chaos drain away the last of their relative motion. The elegant disks we know today will be completely erased, their graceful spirals shredded beyond recognition. What remains will be a single, colossal elliptical galaxy, smooth, featureless, and almost perfectly spherical, bathed in the soft reddish light of ancient suns. Astronomers have already named this future titan Milkomeda. Milkomeda will be a city of well over 1 trillion stars orbiting a new, central, supermassive black hole, the fused offspring of Sagittarius A star and Andromeda's far larger monster, perhaps 100 million solar masses or more. Its shape will be the inevitable endpoint of every major merger, a glowing football of old stars, no longer forming new ones, quietly cooling in the darkness as the universe around it continues to expand. The Milky Way and Andromeda will not survive the embrace. They will become something grander, stranger, and utterly alien. And from a vantage point billions of years from now, no one will ever know there were once 2, from whatever remains of Earth, or from the safe orbit of some future habitat. The approach of Andromeda would be the most spectacular sight our species will ever witness. At first, it will be subtle, a faint glow in the northern sky growing imperceptibly brighter, decade after decade. Then, in the last few 100 million years, the change will accelerate. Andromeda will swell from a smudge into a vast luminous band, eventually stretching from horizon to horizon, its spiral arms resolving into shimmering rivers of starlight so intense they cast shadows on the ground. On the clearest nights, it will outshine the moon. In the final millions of years, it may become visible in broad daylight, a second, ghostly Milky Way hanging overhead. As the galaxies begin to overlap, the sky will erupt. Shock waves of colliding gas will ignite chains of new stars, blue-white beacons flaring into existence by the millions, turning the merging disks into a tapestry of sapphire and ruby fire. Long, tidal tails will stream outward like glowing ribbons, while rogue stars flung from their orbits streak across the heavens in slow, majestic arcs. The familiar constellations will dissolve, replaced by a chaotic, ever-shifting ocean of light that no human culture has ever named. This is not destruction. It is rebirth on a scale almost too vast to comprehend. The collision is the ultimate proof of Andromeda's true size and power. A structure so colossal that it can reach across 2.5 million light-years, swallow our entire galaxy, and transform both into something new. It reminds us that nothing in the cosmos is permanent, not even the great spirals we thought eternal. Everything is in motion, everything is part of the same slow, patient dance of gravity that began with the first collapse of matter after the Big Bang. The universe is not a museum of finished objects. It is a living, breathing storm of creation and renewal. And in 4.5 billion years, the storm comes home. The true scale of Andromeda is not just a matter of light years and solar masses. It is a direct confrontation with some of the deepest mysteries we have ever faced. First, dark matter. Andromeda is the finest laboratory we will ever have for studying this invisible substance. Its elongated, football-shaped halo is the gravitational skeleton that keeps 1 trillion stars spinning in perfect order. Without it, the galaxy's rotation curve, the speed at which stars orbit the center, should drop off sharply once you pass the visible edge. Instead, it stays stubbornly flat, far beyond where ordinary matter ends. That flatness is the smoking gun, something massive, unseen, and utterly indifferent to light is holding everything together. 85% of Andromeda's mass is this dark scaffolding, and because Andromeda is so large and so close, every measurement we make of its stars, gas clouds, and satellite galaxies becomes a probe into the nature of the stuff that actually runs the universe. We still don't know what it is, but Andromeda is the clearest mirror we have for seeing how it behaves. Second, the cosmic web. Andromeda and the Milky Way do not exist in splendid isolation. They are the twin anchors of the local group, which itself sits on a filament of the much larger Virgo supercluster, a glowing thread in the vast, sponge-like network that stretches across hundreds of millions of light-years. The motion of Andromeda is not a simple two-body waltz. It is shaped by the cumulative tug of every galaxy, cluster, and void in our cosmic neighborhood. The dark flow we feel, the slight sideways drift that might let Andromeda graze us instead of hit us head-on, is the whisper of that greater web flexing. Andromeda's immense gravity is one of the main knots tying our corner of the web together, and its collision with us is simply the most dramatic local consequence of a structure that spans scales we can barely map. Third, and perhaps most humbling, the relativity of space and time. When you look at Andromeda tonight, you are looking 2.5 million years into the past. The photons now slipping into your retina left their home before Homo sapiens existed, before the first stone tools, before the savannas of Africa rang with anything that could be called human. In that single glance, the enormous distance collapses into a single moment. Space becomes time, and time becomes space. Andromeda is not just far away, it is long ago. Every galaxy we see is a message from a younger universe, but Andromeda is the only one close enough, bright enough, and large enough to make the message feel personal. It is a living time machine hanging in our sky, reminding us that the cosmos is not a collection of objects scattered across space, but a single four-dimensional tapestry where every point is connected to every other by light that has been traveling since the dawn of stars. Andromeda does not just dwarf us in size, it dwarfs us in meaning. It is distance, darkness, time, and destiny, all woven into one shimmering arc we can see with our own eyes. The journey to grasp Andromeda has been nothing less than humanity's slow, painful surrender to cosmic humility. It began with a little cloud, a harmless curiosity scribbled into star catalogues 1,000 years ago. Then came the shattering revelation that the cloud was another galaxy, millions of light years beyond our own, forcing us to abandon the comforting illusion that the Milky Way was all there is. And now we face the final demotion. This trillion-star titan is not content to remain distant. It is already falling toward us, its dark halo merging with ours, its gravity rewriting our future. In 4 billion years, the Milky Way as we know it will cease to exist, absorbed into a new elliptical giant we have already named Milkomeda. Our galactic identity, the very name we give our home, will be erased and reborn. This is cosmic patience in its purest form. The merger will unfold across billions of years, a timescale so vast that the entire rise of life on Earth, from single cells to cities, is less than a rounding error. Our recorded history is a flicker shorter than a single orbit of a star near the Sun. Andromeda teaches us that the universe does not hurry. It waits. It pulls. It reshapes everything according to the quiet, relentless mathematics of gravity. We are not the protagonists of this story. We are not even supporting characters. We are passengers on a small blue world, circling an ordinary star, inside one spiral arm of one galaxy that is itself about to become a footnote in a far greater tale. Andromeda's true scale is not just size or mass or distance, it is possibility. 1 trillion suns, 100 million black holes, dark matter halos vast enough to swallow solar systems whole, all of it locked in a slow, majestic dance that will outlast every monument we will ever build. It is the scale of a universe that keeps creating, destroying, and reinventing itself long after our species is gone. Even with the mightiest telescopes we have pointed at it, Andromeda still guards secrets. Its bright core is mapped in exquisite detail, but the faint outer halo, the true boundary of its power, remains a shadowy frontier, a realm of sparse stars and tidal debris where new discoveries wait. The galaxy is so large that light from its farthest edges takes hundreds of thousands of years to reach the center, meaning we are always seeing different parts of Andromeda at different moments in its own history. Andromeda is not finished growing, neither is the universe, and we are privileged, terrified, humbled, exhilarated to watch the next chapter begin with our own eyes. One of the most revealing windows into Andromeda's titanic history lies in its retinue of globular clusters. Those ancient, densely packed spheres of hundreds of thousands of old stars that orbit far beyond the bright disk like a swarm of golden bees. Andromeda hosts at least 460 of them, 3 times more than the Milky Way's roughly 150. And that surplus is no accident. Many of these clusters did not form with Andromeda. They were stolen. Each one is a surviving relic of a smaller galaxy that wandered too close and was torn apart. Its stars scattered into the halo while its globulars were captured like trophies. By measuring the ages, metallicities, and orbits of these clusters, astronomers can reconstruct a violent biography. A major merger around 10 billion years ago. Another significant meal 2 to 3 billion years ago. And a steady diet of dwarf galaxies ever since. The clusters are frozen fossils, their chemical fingerprints telling stories of long-dead parent galaxies that now live only as ghosts in Andromeda's halo. Scattered across a volume hundreds of thousands of light-years wide, these glowing orbs map the true extent of Andromeda's reach. Some orbit so far out that they trace the very edge of the dark matter halo itself, marking territory the visible galaxy barely hints at. Their sheer number and spread are a direct physical testament to Andromeda's scale and its ruthless past. A galactic predator that has grown not just by birthing stars, but by devouring everything in its path. Every cluster we catalogue is another piece of evidence that the quiet spiral we admire tonight is only the latest chapter in a billion-year saga of cosmic cannibalism, and that our own Milky Way, with its modest collection of globulars, is simply next on the menu. Beyond the stars and the dark matter halo lies another unseen titan, Andromeda's circumgalactic medium, or CGM. This is the galaxy's invisible atmosphere, a vast, diffuse sea of million-degree gas, stretching out to nearly 1.3 million light-years from the center in every direction. Hubble's ultraviolet spectrographs have caught it in the act, absorbing specific wavelengths of light from distant quasars that happen to shine through the halo. The result is a ghostly sphere of plasma so large that it already overlaps and intermingles with the Milky Way's own CGM. Long before a single star from Andromeda crosses our sky, the hot breath of the two galaxies has already begun to mingle. The CGM is both pantry and graveyard. It holds as much mass as all the stars in the visible galaxy combined, billions of suns worth of hydrogen and helium, slowly raining inward to feed future generations of star formation while catching the ejected ashes of supernovae and stellar winds blown outward by dying suns. It is the galaxy's slow respiratory system, inhaling pristine cosmic gas and exhaling enriched material in a cycle that has operated for billions of years. When the merger finally arrives, this gaseous halo will be the first to feel the shock. The two CGMS will slam together long before the bright disks do, compressing and heating to temperatures of tens of millions of degrees. Shock waves will ripple through the plasma, triggering early bursts of star formation and stripping gas from both galaxies in long, glowing tidal tails. The stellar collision we visualize, the dramatic intertwining of spiral arms, is only the visible finale. The real opening act is already playing out in the dark, in a hot, invisible embrace that began hundreds of millions of years ago. Andromeda is not just approaching. Its atmosphere is already here, brushing against ours like the first warm gust before a storm. The true scale of our neighbour is not measured in stars alone, but in the invisible oceans of gas and plasma that have been reaching out across the void long before we ever noticed. Andromeda's ultimate, most haunting scale is not measured in light years or solar masses, but in possibility. 1,000,000,000,000 stars means 1,000,000,000,000 chances. Even the most conservative estimates, one habitable zone planet for every 1,000 stars, one living world for every 1,000 habitable ones, still leave us with millions of potential biospheres. Inside that single spiral, if the spark of life is anything more than a miraculous fluke on Earth, then Andromeda must be teeming. Oceans beneath alien moons, microbial mats glowing under red dwarf light, perhaps even minds looking back across the Gulf, wondering the same thing. We wonder when we stare at the Milky Way. Every night we see Andromeda, we are looking at a parallel experiment in cosmic evolution, running for billions of years, completely isolated from our own. 1,000,000,000,000 suns, each with its own retinue of worlds, each world following its own chemical and biological path under slightly different laws of gravity and starlight. The light reaching us tonight left before our ancestors learned to walk upright. Whatever life it illuminates has had all that time and more to rise, fall, or reach levels we can barely imagine. Andromeda is not just a galaxy. It is a second roll of the cosmic dice, a billion-fold repetition of the same question Earth once asked alone. Can chemistry become life? The numbers are merciless. If life is rare, Andromeda is still a garden. If life is common, Andromeda is a universe unto itself. Either way, when you look at that faint smudge in the sky, you are not just looking across space. You are looking across possibility, at 1,000,000,000,000 silent answers to the only question that truly matters. And one day, 4 billion years from now, when the two galaxies finally merge into Milkomeda, those answers will become part of our own story forever. The true scale of Andromeda is not a number you can hold in your head. It is a feeling that settles in your chest when the math finally gives up and all that is left is wonder. It is measured more by what we cannot see, the dark matter that outweighs every star, the hot gas halo already touching our own, the billion worlds we will never visit, than by the light that has travelled 2.5 million years to reach us. It is the quiet realization that the faint smudge we have dismissed for centuries is not a background decoration. It is a living, breathing colossus whose gravitational whisper has been pulling on our galaxy since before Earth had oceans. We began this journey with a ghost in the sky, a little cloud that turned out to be an empire of 1,000,000,000,000 suns. We followed humanity's long surrender, from the center of the universe to the edge of the solar system, to the suburbs of one galaxy among countless others, until Hubble's single Cepheid kicked the walls down and made the cosmos explode in size. And we ended staring at our future, Milkomeda, the fused titan that will one day erase the names Milky Way and Andromeda from the sky forever. That is the gift Andromeda gives us. Not just facts, but perspective. The same gravity that pulls an apple to the ground is the force that has been guiding 2 trillion stars toward their rendezvous for billions of years. The same light that warms your face on a summer day is the ancient glow of suns that rose and died before our ancestors learned to walk. We are woven from their ashes, bound by their laws, and headed toward their embrace. This is why we explore at Cosmodepth, not to lecture, not to overwhelm with numbers, but to stand beside you under the night sky and let you feel the pull for yourself, the chill of deep time, the heat of 1,000,000,000,000 nuclear fires, the slow, patient heartbeat of gravity that never stops. Look up again tonight. That faint smudge is no longer distant. It is family, and it is coming home.